I know the results here are extremely controversial. I know that my mainstream friends are all going to say this guy is crazy. But if you think I am, then I challenge you to prove that I am wrong. And you do that by repeating this experiment and seeing whether you get the same results. That is a primary cornerstone of proper scientific procedure, is that.
Okay, so what I did is check your claim about the ball dropping 4 times the high. To you, it gave you 2.8 times the velocity. I checked this with my own experiment and found out that it's roughly twice the velocity, not 2.8 times the velocity. And I think I know why, sort of part of the reason at least. Let me show you first what you say.
Which I have the data over here, found that, when you're at 4 times the height, you're actually going something like 2.8 times as fast. So the thing is that they thought the ball.
So you think it's 2.8 times as fast because you used your camera, which is 90 frames per second. And what is 90 frames per second? How many milliseconds pass between each frame? So we can calculate 1 second divided by 90 frames. So every 0.01 seconds you have a frame. The experiment I carried has a different frame rate than yours, higher frame rate. So I have better resolution. My resolution is shown. I can show you the file. So these are every time I take a snapshot of a measurement to see if there is an obstacle between the sensor and a light, if an object passed through it, so that I can measure the velocity. So you can see over here, this is the milliseconds, 119 milliseconds, 121 milliseconds. So that's a step of 2 milliseconds, 0.002 of a second, right? So I have higher resolution, though sometimes because the computer does what it does, skips 50 milliseconds every now and then, but unless the measurement falls in that bucket, it doesn't matter, because I have a decent resolution sometimes of 1 millisecond. See the skip here, 246 to 247, but usually like 2 milliseconds resolution, which I can use to measure velocity. So let me show you my experiment. So over here is the video. Let me mute it. So I delete the log file, then I upload to the Arduino. I'm using an Arduino to take the sensor data. Then I communicate with this program in the left up so that the Arduino can log the information into my computer. Then I set up the device. In the wall you can see a measuring tape is 1.5 meters long. In the last 10 centimeters I have 2 sensors. One 10 centimeters above the end and one at the end of the measuring tape. So the last 10 centimeters I measured the time at which the object falls through them. So if there is a blockage of light, then there is the object blocking the light and giving me a measurement. So let's say I do the experiment, I turn off the light, then I have the data over here. It's huge because every 1 millimeter, like 1,000 measurements per second, so it's a lot of data. Then I plot it in a graph, and you can see over here. I'm going to pause the video. This is an example of the data that I get. I have actually 5 sensors. I only need 2 to measure the velocity. I put 5 sensors. So the orange and the yellow one have a minima, and I use the minima between the two to measure the amount of time that the object was blocking the light in one sensor and the object was blocking the light in the other sensor this distance difference in time, it's not distance, it's difference in time, I can use to calculate the velocity, because the velocity is equals, what is it? Change in distance over time. So the change in distance is going to be 10 centimeters, and this is the change in time, the time that it took between one minima and the other minima. So okay, so that's basically the experiment. Let me show you my data. So okay, here's an example of the data that I was getting from the experiment. So I ran the experiment 3 times for a height and then 4 times the height. In the left you can see the height over here, 36, right? 36 centimeters from the end of the tape, and then 4 times the height, 144 centimeters from the end of the tape. So in the left I'm getting the difference between the first sensor measuring the time and the second sensor measuring the time at which they were blocked. And at the right, I'm measuring at 4 times the height, the first sensor time at which light was blocked, and the second sensor time at which the light was blocked. So in the left, the 1 times the height, I'm getting 43 milliseconds difference. At the right, I'm getting 20 milliseconds difference. And it's pretty consistent, except for these 2 values, which I probably messed up somehow because I was getting just ridiculous values, 198. So I put them in red. Maybe a mistake, probably, because everything else, every other run I did is fairly consistent with 4 times the height, twice the velocity. Because this is, if it takes half the time to pass through both of the sensors, that means that is basically twice the velocity if you compute the math. We don't need to actually calculate the velocity. The distance traveled in the end of the tape is 10 centimeters. So you divide that by the milliseconds and you will get the value. So okay, let's do one of these. Let's actually calculate the velocity. So 1 times the height, we get the difference between 5,931 and 5,974. The difference 43 milliseconds. So what is 10 centimeters divided by 43 milliseconds? 10 centimeters. Okay, you get that. So now let's calculate for 4 times the height, the first run. So it's gonna be 10 centimeters divided by 20 milliseconds, 5 meters per second. And we were getting 2.3 to 5 is fairly accurate, but it's not accurate enough. My resolution still produces some error because there's like a jitter of 2 milliseconds, sometimes huge, but just changing 1 millisecond changes the value significantly. See, 2.4 instead of 2.3, 1 millisecond. Now you have centiseconds, hundredths of a second error in your measurements, which must cause significant, because you're changing something like instead of a 4, it's a 3. And the value is drastically different. I think this is the source of your error, part of it at least. Another possible problem with your experiment is that you're using one point to take the measurements from. So there's probably some parallax, it's called, like the object, the car is traveling on above the measuring tape, and from the angle you don't see the measuring tape consistently to the point, reference point that you show, the white line in the car. So yeah, I think for these reasons we should dismiss your proof that kinetic energy is wrong, because depends on a setup that has these types of errors. So I think it's proven, at least to me, that 4 times the height gives you twice the velocity. Yeah. Okay. I think that's it.